just gets to be a lot here to do.
Yeah.
X squared minus 4 over 4x. So this ends up being 3/4. At least that's
Hmm.
what I've got.
Yeah.
And then minus 3/4 over 3. All right. So this is 6 over 4 over 3, or 3 over 2 over 3, which ends up being 1/2.
Hmm.
Is that okay?
Yes.
All right. Now, in terms of taking the derivative of this, I would do a rewrite here. I would not use quotient rule. So you can rewrite it as x over 4 minus 1 over x, like that.
Okay, wait. So, okay, yeah.
Now, I don't know. I mean, it might be that quotient rule is the way to go. I generally prefer not use quotient rule. So
Oh, I was to use the quotient rule. I don't know if like like it's mandatory to use that, but
you do not have to use quotient rule on this problem because you can divide each of these by 4x. Now, problem like number 1, you have to use quotient rule on. Number 4, you have to use quotient rule on. 6, you have to use quotient rule on. So we can do one of those in a moment. But if you can divide each of them, you should. It saves you time because your derivative is so much easier. This is
Mhm.
just 1/4, and this becomes plus 1 over x squared. Now, are you guys up to the point where you're pretty fast on derivatives, or are you still kind of muddling through with, all the rules?
Um,
Like, do I need to
yeah,
explain? Do I need to explain this basically?
no.
Okay. So you set this equal to 1/2, the C value, or that's the average rate of change. And there's some C value that's between A and B that this works for. So when you subtract 1/4, you get 1 over x squared equals 1/4. And so you find that x is either plus or minus 2 to do this. And so you want the one that's in this interval. Like, it's really important that you don't just say they both work. You have to say that only the one in the interval work.
Wait.
Question?
Yeah. I'm trying to figure out how to phrase this. So, wait. What do you mean by like it has to be in the interval?
There's two answers to this problem,
Hmm.
but only one of them is between minus 4 to minus 1.
Oh, okay. So
Minus 2
negative
is there.
C.
And yeah, and they're not both correct. Um,
Okay.
even though they're both solutions, you only want the one that's in the interval.
Hmm.
Okay, so that, your answer is x equals minus 2, and that's C. I mean C is minus 2. Is that okay?
Yeah, yeah, yeah. Okay.
All right, all right. All right, let's do you have a preference for 4 or 6 or
Um, let's do 6.
okay. 3 and 5 are power rule with chain rule derivatives. Are not as comprehensive or not as difficult. So you got to do the whole like f of 2 minus f of 0 over 2 minus 0.
Hmm.
That could be the most. You got to get this part down, or it's just really, really bad because you end up solving for the wrong thing. X squared 2x plus 2. Okay, so we got 2/3 minus 1/2. Sorry, minus 0, not 1/2. 0 over 2. So this ends up being 1/3.
Wait. Um, I'm sorry. How did you get 2/3?
I used a calculator and it worked out. Let's check it out here. So 2 squared 2 times 2 plus 2.
Okay. I'm sorry. I was so confused for a second.
No,
Okay.
I'm not, I'm on a, so I've got another screen where I'm doing a lot of calculations and things,
Hmm.
you're not seeing, uh, but yeah, please ask, because
Okay.
I
Sorry
guess
about
I'm,
that. I was confused, but I get it now.
yeah. Well, I put the wrong number here first, so it's gonna happen. So that's what we're gonna set the derivative equal to. So this one you have to use quotient rule.
Yeah.
You have to. And this is the one, you don't want to, students don't like. Do you need me to work it out to explain it, or can I just write the derivative? Do you need explanation or not?
Yeah. Could you just explain this one?
Okay, so there's a rewrite step here, sort of, where there's a top and bottom. And I like U and V. The reason is because these are letters you'll use in the later in the course.
Hmm.
Sometimes books use F and G. So if you don't like that, I'll sometimes say the words top and bottom.
Hmm.
You have to take the derivative of each. And so the derivative is, whether using U and V or F and G or whatever else you're using, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared, like that.
Hmm.
So are you comfortable with kind of building this U and V, F and
Yeah, we
G?
use F and G, but I like it better using U and V. It makes more sense to me, I feel like.
Yeah. Um, it's not quite the same as the product rule, although it's got some similarities. Um, Now, you are not required on the AP exam in the free response to simplify your derivatives,
Hmm.
but in the multiple choice or in a problem like this, you have to. And
Hmm.
that's where it tests your algebra. So this 2x multiplies both of these. It's 4x squared plus 4x minus 4x squared. And so those cancel, and you get 4x over 2x plus 2 squared, like that.
Okay.
And you're setting this equal to, all equal to 1/3. We'll just check this. Sorry, this is wrong. I made a mistake here. All right, 2x squared. So you end up getting 2x squared plus 4x. Sorry, this is all bad. 2x squared plus 4x all over 2x plus 2 squared, like that. And we're setting this equal to 1/3. I can't believe this worked. Let me check this before we proceed,
Okay.
just to make sure that this actually is going to work. X squared. Okay, so they factor that out. Uh, 4 is with that 2. Yeah, okay. So this works. Now does this actually solve? Let me see if this works out nicely. Yeah, this doesn't work out that great, but okay. So we can solve it from here by multiplying, cross multiplying here.
Hmm.
So 6x squared plus 12x equals 2x plus 2 squared. And then you got to get really fast at foiling this.
Hmm.
4x squared plus 8x plus 4. Especially you're gonna take more math. If you're not, then you'll be okay. Minus 4 equals 0. So moving stuff around and factor out a 2. And so this has to be solved using quadratic formula. Uh, Unfortunately, you end up getting -1 plus or minus the square root of 3 when you solve it using that.
Okay.
Now, only one of these is probably in that interval. We did all that work again.
Mhm.
So from 0 to 2. So it's the -1 plus the square root of 3 that you want. That's going to be in the interval.
Okay. So
Minus
then,
1 minus the square root of 3 is not. It's too negative. Sorry, go ahead.
no, 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 nothing. I was just like trying to understand, but I understand.
Okay. I think, yeah. Is that from 0 to 2? Yeah, that one's in there. Okay.
So do they
Any,
usually solve out like pretty bad, or is it like,
it's uh these are pretty challenging. You don't get them this difficult on the AP because on the multiple choice you don't have enough time to do all this. This is
Mhm.
like this is like a it's not a free response question. It's just a long question.
Mhm.
No, they're not usually this bad. So like if I were a student or if it to help you kind of navigate this, like the easier ones you should be able to do. These other ones, I mean, maybe, but they're a lot of effort. Um, do you want us to do any of 3 and 5, or do you want us to move on to the next grouping of questions?
I think I'm good on 3 and 5, so we can move on to the next one.
Okay, related rates. You could have had a lot of problems in the section on related rates. There's circle problems, there's cube problems, there's I don't know, there's triangle problems, ladders. Does that all sound familiar, or is that
Kind of. We haven't really done this. I don't know why my teacher randomly brought it up, but we haven't really worked around this.
okay? Have you done implicit derivatives yet?
No, I don't think so.
Okay, this all right, let me just do this problem then, and you can decide later how much you want to take from this. So
Okay.
the area of a circle is pi r squared.
Hmm.
Um, the what they're giving you in the problem is they're telling you that the radius is increasing at 3 feet per second. They're telling you dr dt equals 3. And so the reason that this is known is because radius is really a function of time. That's why
Okay.
it's got a time derivative. So dA dt, the derivative of area with respect to time, is 2 pi r, that's power rule, times the derivative of r, that's the chain rule, that's dr dt. And that's why I said none of this makes sense. It will when you actually get to the section. So how fast is the area taken up by the crowd increasing? They're basically asking for, this is dA dt, and you have the radius is 3. That's right there. The radius is 3, and dr dt is also 3. So this ends up being 18 pi, and then the units of area are feet squared per second.
Okay.
Um, is that okay for 7? Maybe.
Yeah. Yeah, I'm good for 7.
All right. So let me just make some comments here about some of the next ones. So 8, which we should not do. 8 is a quotient rule problem because we've already done a quotient rule problem.
Hmm.
9 and 10 have some simplifications that we should talk about. You should always try simplifying before you take a derivative. Let me just
Hmm.
take a look at this one. And these are why the instructors like these, because if you don't notice these things, they make the problem a lot harder. Like the top one, you can factor a 4x squared out, and
Hmm.
then you get x squared plus 1 inside there.
Hmm.
And then on the bottom here, if you factor the 5 out, you get x cubed minus 1, which doesn't really help. But like the bottom here would expand to x minus 1, x squared plus x plus 1. That's the sum and difference of cubes formulas. But
Yeah,
this one doesn't, like, I was looking ahead, like maybe this one simplifies or something, like you get a cancellation. Like none of this is useful, unless I've made a mistake here. Like none of this helps. So this is
yeah.
just another quotient rule problem.
But you
10
should always
looks,
check, right?
yeah, if you can, yeah, it'll save you a ton of time. And I don't think unlike the AP multiple choice, there's a bunch of stuff like that. Um, yeah, this one, like the top, again, the top kind of factors, it becomes x squared minus one, x squared plus one. And then the bottom becomes 4 times x squared minus one. And so you can see that these cancel, and then it's a pretty straightforward derivative. It's 1/4 times x squared plus one, or you can write it as 1/4 x squared plus 1/4. The derivative is just 1/2 x. Everything else is just a leading into that. And that's why I'm so surprised 9 didn't have something like that. It looked like it was heading that direction, but it did not.
Yeah.
So yeah, I mean, you try. Um, you can also do polynomial, and that's maybe what they're, I don't even know what they're thinking here. You could do polynomial division.
Yeah.
Was that covered in class?
We covered it in college algebra, but we did
Right.
not class.
Like I've never seen that, but I don't know. Your teacher, they got a background in something where they got a doctorate, so maybe they're being really fancy here. I've never seen polynomial division taught as part of calculus doing derivatives. These
Hmm.
all look like quotient rules. They just like horrible quotient rule
Yeah,
problems.
what it is.
So up to you if you want to do more of those. Is that sufficient for 8, 9, 10, 11, or do you want more thoughts on those?
Um, could we just hmm. No, yeah, I think we're good for those.
I'm happy to do one. I'm not trying to get out of it or not, it's all the same to me.
Actually, yeah, can we do number 9? Since that one doesn't like simplify it down.
Sure. All right, so again, u is 4x to the fourth plus 4x squared. V is 5x cubed minus 5. You'll notice when I do this, I'm very particular. I always do the top and then the bottom. I always make it sort of in a table. I would be very organized as a student here. That really makes a huge difference, especially when these
Mhm.
problems get more difficult. All right, so you need those. And now so what some students do is they do write the derivative. Okay, it's bottom times root of the top minus top times root of the bottom over the bottom squared. And maybe you're using f and v, that's fine. Like it really doesn't matter. Like this. Okay, whatever way you want to do it is fine. And then you're just putting these pieces in, but you put them in parentheses. So v, even if it's one term, 15x squared 16x cubed plus 8x. Part of the reason is for readability. It just really helps to separate the terms. Maybe you've got really clean handwriting. I don't, so I have to do this
Mhm.
to make it nice. And then what am I doing here? Sorry, I'm really messing this up bad. All right, I messed this up. I am sorry for that. All right, 16x cubed plus 8x minus 4x to the fourth plus 4x squared times 15x squared over 5x cubed minus 5 squared. Did your instructor talk to you about that you do not generally simplify these unless you were told to?
No, he does not talk to us about a lot of stuff.
Okay, that's a big deal here. Like I know you can foil it, I can foil it. I don't know if anything nice happens, but generally it's like they say like do not simplify or simplify like because they know how messy these are because that's not part of your course. On the
Hmm.
AP multiple choice, you do have to simplify, but you get like one of these. You don't get like 10. It's like one. So, I mean, do you want us to foil and subtract? What would you like us to do here?
Um, if we don't have to simplify, then I think we're fine for
Well,
that.
remember, I don't know the answer to that. I'm just saying that's a good thing to check.
Um, yeah, we could, yeah, foiling is good.
Okay, so this becomes 80x to the sixth plus 40x to the fourth minus 80x cubed minus 40x. And then this negative distributes into both of these, so it's minus 60x to the sixth minus 60x to the fourth. And so what do we got here? That could, so these two combine to 20x to the sixth plus 20x to the fourth uh, minus 80x cubed minus 40x all over this. And the question is like, where do you stop? Because really this bottom, you can actually rewrite it this way: x cubed minus 1 times 5 squared, 25 squared is 25, and that can go in a bunch of these to simplify, or you take a 5 out of everything. That's
Hmm.
where I don't, I feel like I'm doing you a little bit of disservice where, yeah, you could take a 5 out of that bottom and it becomes 4x to the sixth plus 4x to the fourth minus 16x cubed minus uh, 8x all over 5 x cubed minus 1 squared. Is that better? I have no idea. I
Um,
mean, you could factor a 4 out of the top two now, and
I'm just like confused as to like where you would stop.
yep, that's why
Like
that's why. Well, not
even in
here.
like yeah, even in class it's been like up in the air where you're supposed to stop. Like he doesn't really clarify.
So keep asking. Really important to keep asking because you'll. This is a good skill for college too.
Hmm.
Don't assume. Um, and I'm just looking ahead here. Does this like x squared? Does that become so? Sometimes like you get grouping in here. It doesn't look like it.
Hmm.
X squared plus 1. No, so I guess maybe here, maybe.
Yeah,
All right. Has your teacher helped with the class before, like to get students ready for the AP?
not really.
Okay. All right. This is being taught more like a college calculus class, which I know that's what you're in, but there the AP is not like a college final in
Hmm.
calculus. Okay. Number 12, find the open interval where the function is increasing and decreasing. Encoded in this is to take the derivative. Could you take the derivative for us, please?
Yeah. It would be 4x uh minus 12.
Good. You set that equal to 0 and you solve for x and you get x equals 3. So on a number line here for your derivative, your critical point is 3, and then you need to test points like 0 and 4. So these are your test points. You test them in the derivative. So you're putting 0 in the derivative, 4 in the derivative, and you want to know whether it's positive or negative. Did we cover this before?
We did, but how do you like find which is there like a specific like way to figure out which points you test, or do you just pick numbers around?
Anything less than 3, that is nice. Like 0 is a good one, 1's a good one. Anything greater than
Okay.
3, you know, don't get too extreme. But
Okay, thank you.
so 0, 4 times 0 minus 12 is negative 12. That's negative. 4 times 4 minus 12 is 4, which is positive. And so we're looking for where it's increasing and decreasing. It is decreasing. It is decreasing from minus infinity to 3, and then increasing from 3 to infinity, like that.
All right. I do
And
remember
that
us
should,
covering those before.
good. This should make sense. It's some sort of a parabola. So it's decreasing when it's going down and to the right, and then it's increasing when it's going up and to the right.
Hmm.
All right, number 13. All right, can you calculate the derivative on this, please?
Yeah, it would be negative 3x squared plus 4x.
All right, so this time we're going to set it equal to 0. Factor out an x maybe, minus 3x plus 4 equals 0. You set each of those equal to 0. And you end up getting 4/3 and 0. So on your number line, and it doesn't need to be to scale. Like the point of this number line is you're representing the derivative. You're not trying to make this look exactly like where those numbers lie. You'll notice that I switch colors for the test points. You do not want to get anywhere near your intervals because you'll be later on doing problems with the first derivative and the second derivative, and you want to keep this nice and clean so you can organize information. Some teachers use like more of a table. I found the number line to be more effective, but you
Hmm.
are welcome to use, whatever you want for that. Now you're testing it back in the derivative. We have a couple of forms of the derivative. We have this form and this form. They're both the same. You got to choose which one you're going to use. It doesn't matter. Typically factored form is slightly better. Why didn't I put derivative symbol in there? There we go. I think factored form is slightly better, but that's up to you. The
Hmm.
more math you take, the more choices you get. So we want to test -1, 1, and 2 in the derivative here. Could you do that for us and let me know whether it's positive, negative, whatever it is, negative, positive, negative, or whatever you end up saying there.
Yeah. So the first one would be negative, right?
Okay, I agree.
All right. And then that one would be the for one it would be positive.
Good.
And then that one the two would be negative.
Now it does not always alternate. Like the couple we've done have alternated. It does not always alternate. It
Hmm.
does, and it does for polynomials for the most part, but not not as general. So just always test your points. So this time it's decreasing. And if you need to, add in the infinities, where the extremes are. It's decreasing from -infinity to 0, 4/3 to infinity. And then it's increasing from 0 to 4/3.
Okay.
All right.
Okay. Yeah, that makes sense.
Good. So next grouping of questions here. Um, I think that these are meant to be product rule problems, but it's better to actually FOIL and then take the derivative without the product rule. If you were to be given something like this, um, you don't have to use the product rule, even though they're all product. Like when you FOIL it, it's no longer a product. So I don't really understand this assignment because it should say like use the product rule, like it practice the
Yeah,
product
yeah.
rule or not. But like I'll just I don't know, I'll pick 15 here for the moment. So if you FOIL first, you get 25 x to the seventh, minus 10 x to the fifth plus 25 x squared minus 10. And then your derivative is the power rule. It's 7 times 125, 175 x to the sixth minus 50 x to the fourth plus 50x, and you're done. Whereas, like, let's just say we're going to work on 16 and we're going to use product rule. We have to do a bit more to set it up. And that is until you get comfortable with this. You'll be able to do it on the fly at some point
Hmm.
here. And once you have your two derivatives, maybe you so for product rule, you are always combining them diagonally. So you can just get in the pattern of doing that.
Oh
It's a
yeah.
little bit of, but not quotient rule. Just be careful on that one. So again, this comes to the point of like, well, are you simplifying or not? Because if you're not simplifying, maybe this is better. If you are simplifying, like I would argue it's better to FOIL first and then use the power rule. So I don't know. I don't know what to say. This one you'd have to multiply in, combine like terms maybe. I don't know. Do you have any thoughts on that?
Um, I think that I mean, since he didn't specify, I could make a case to be like, oh, well, you didn't specify, so I use the FOIL. I feel like that'd be a lot easier to like FOIL and then take the derivative.
It is. It is. And it works for these. It works for these. Now it
Mhm.
like I kind of noticed that you guys are not doing, you haven't introduced like trig functions and E and LNs, things like that.
Uh-uh.
You will not be able to just FOIL then. But like, I mean, you might ask, that's just a thought if you're comfortable. Hey, I was working on these for the weekend. I noticed I can just FOIL them. Is that okay?
Hmm.
I mean, it is, but maybe that's not what they want.
Yeah, it's very like up in the air what we're supposed to do. I don't know. It's very confusing.
I get it. I get it. Okay. Can we go to 18, 19, 20, 21 now?
Yes.
All right. Let's look at 18 first. So these are quotient, not quotient, sorry. These are power rule, chain rule problems. Have you guys talked about the chain rule?
Yes, we have.
Oh, good. Oh, good. Okay. This requires a little bit of rewrite. It's really square root of 2x to the fifth plus 1 minus 5 to the 1/3 power. And then you might even further rewrite it as 2x to the fifth plus 1 to the 1/2 power minus 5, 1/3. So
Hmm.
the outermost function here is the exponent, So that's your first uh thing you're doing for derivative. So you're uh when you're but like what maybe is, and I don't know how comfortable this is, what you're really doing here is you're writing this as u to the 1/3, where u is all the stuff inside parentheses. So your derivative is 1/3 u to the minus 2/3 times u prime. Have you seen this before, or is this totally new?
I don't think I've seen it before.
So you guys, you've not been doing chain rule, or you're just not really seeing much with the way of chain rule, because these are pretty tough chain rule problems.
I We have been doing chain rule, but I'm just kind of confused on it. And a lot of the problems that we did in class were easier, and then the homework's just harder, so it just does not help.
Yeah, this is not a great place to start. Should they? Um, okay. Um, well, oh boy. So yeah, I don't want to make it too easy, but I mean, at some point though, we need I don't even know what to suggest. I mean, these are all like more difficult. 18, 19, 20, and 21 are all pretty difficult chain rule problems.
Hmm.
Okay, why don't we do this? We'll come back to this. Because
Hmm.
22, we got a second derivative on that. Those are awful. Yeah, never mind. Okay. So the idea with the chain rule is that you're going to make a substitution to make it so that you can take the derivative. Like you don't know how to take the derivative of this line right here. You don't have any idea how to take the derivative of this. Like I don't either. But if I make it u to the 1/3 power, I do know how to take the derivative.
Hmm.
So it's like turning something you don't know into something you do know. But when you take the derivative here, there's an inside function. That's why you're multiplying by the derivative of u prime. So now we've got to come over here and figure out what is u prime. Well, the problem is we've got another issue here, which is like we don't know how to take the derivative of this either. So we're going to make yet another substitution. This is really v to the 1/2 power minus 5, where v ends up being, I'm going to run out of room here, but let's see if I can go over to the right here a little bit. V is 2x to the 5th plus 1. So u prime is 1/2 v to the minus 1/2 power times v prime. And then you've got to come over here and find v prime, which is 10x to the 4th. And now you just start substituting in for all the stuff that you don't have. So like instead of u, you're going to put this in. U prime, you're going to put this in, but you got to substitute in back in for that. So u prime is really 1/2 v. V is 2x to the 5th plus 1. V prime is 10x to the 4th. I'm just grabbing those from over here. And so now when you substitute in for u prime, it's all in terms of x. U is in terms of x. So your derivative is 1/3. U is really all of this stuff up here. 2x to the 5th plus 1 to the 1/2 minus 5 to the minus 2/3 power times u prime, which is 1/2 2x to the 5th plus 1, 10x to the 4th, like that.
Okay.
Do you want, like, maybe I guess we can do a few more of these.
Yeah, I think we
Yeah,
do
there's probably,
at least like one more. I don't, it's just very
these
challenging.
aren't the best ones to be starting with, but they're what you
Hmm.
have for homework. Okay, so this one again, I'm going to rewrite it as just, I'm going to rewrite it as y equals the square root of u, and u is minus 5x cubed plus 3 to the power 4 plus 2. So the derivative of y prime, this is really u to the 1/2 power. Your derivative is 1/2 u to the minus 1/2 power times u prime. And the
Hmm.
problem is you're like, okay, now I got to go get u prime. I know what u is, but now I need u prime. Well, u has this issue as well. U is really v to the 4th plus 2, where v is minus 5x cubed plus 3. So u prime is 4v cubed times v prime. V prime is minus 15x squared. All right, so you know what u is, but u prime's in terms of v, so you go and substitute in for v. So your prime is 4 minus 5x cubed plus 3. V prime is minus 15x squared, like that. And so
Hmm.
all of this is now u prime. U is this. So we've got y prime equals 1/2 u, which is minus 5x cubed plus 3 to the 4th plus 2. That's all the stuff up here. Times u prime. U prime is 4 minus 5x cubed plus 3 minus 15x squared.
Okay.
20 is kind of like 18. 21 is kind of like 19.
Okay. Yeah, I think I do understand. It just will take me a little bit longer to like figure out how to do them, but I think I know how to do them.
Okay. Um, right. 22, I guess.
Mhm.
All right. So concavity is the second derivative. Okay, so that means you got to take two derivatives of this thing. So first derivative is kind of what we've been doing. It's this u to the 1/3 power where u is really 6x plus 12. So your derivative is 1/3 u to the minus 2/3 times u prime. And so u prime is 6. So we've got 1/3, 6x plus 12 to the minus 2/3 powers times 6, like that.
Mhm.
Now you simplify derivatives for sure when you're going to reuse them. So in this case, since we got to take another derivative, concavity is the second derivative. You
Mhm.
you do want to simplify here. So this becomes 2 6x plus 12 to the minus 2/3 power. All right, so the next derivative here is kind of like what we were doing. We're gonna do a quick rewrite. It's 2u to the minus 2/3 power, where u is 6x plus 12. So the derivative is negative 4/3 u to the minus 5/3 power. The faster you are at subtracting one, it really will help you out here, times u prime, which is 6. And so you substitute these back in, minus 4/3, 6x plus 12 to the minus 5/3 power. U prime is 6. So you're going to simplify here if you need to. Ends up being a minus 8, 6x plus 12 to the minus 5/3 power. Now, normally you set your second derivative equal to 0. For
Mhm.
concavity, you're looking for potential inflection points. This one, though, has this problem where, because it's a negative exponent, you recall that what this really means is that it's 6x plus 12 to the 5/3 power.
Yeah.
And just a further rewrite here, it's the cube root of 6x plus 12 to the power of 5. All of that being said, there is no place where this equals 0 because it's where the numerator equals 0. So you might be like, well, what do we do? Well, it's undefined, and that's a problem. So you're looking for places where it equals 0 or undefined. And if you have no idea what I'm talking about, which like I totally understand, I'm going to quickly do a sketch of this. So sketch really helps. Like you can actually do calculus is actually better taught with graphing everything. So this is the original function. So right here is a vertical tangent, and the derivative is undefined there. Okay. So it's not just setting it equal to 0, it's also where it's undefined. So you set the bottom part equal to 0 and you get x equals minus 2. So on your number line, you're testing the second derivative now here and here. So you're testing your test points. You might test like 0 and like -3, something like that. Now you can sort of visually do this, like because we have the graph here, you can see that this is concave up. Did you guys talk about the idea that concave up holds water
Yeah, yeah, yeah.
and down does not? But it works through testing points. Like if you test -3 in here, and you probably would need a calculator, you'd have to be really good with knowing signs. This is concave up, this is concave down, like that.
Okay.
Yeah, thoughts on that, follow up to that?
No, I think I'm good for those ones.
Okay. I believe that is everything. We're really close to being out of time. Any other questions? Like maybe I can quickly answer. By the way, 23 is the same as this. You end up getting a
Yeah.
place where it's a vertical tangent as well.
No, I don't think I have any questions. I think you did a very good job at explaining. Like I understand how to do the chain rule and stuff. It just might take me a little more time, but given enough time, I
Excellent.
can do it.
Excellent. Excellent. Glad to hear. I would definitely have taught this differently to you guys, but I don't, it's not I'm not in the classroom, but yeah, there's a better way to teach this, but I'd keep asking questions. You'll get through.